Hi, future doctors. Welcome to the next class. So we were discussing about force. So according to Newton's second law, we wrote force F is equal to dp by dt, change in momentum by time. So they will give graph between momentum and time. So they will give graph between momentum and time. They will ask what is the force. Then what you have to calculate if they gave graph like this or like this. What you have to calculate means slope. Slope of the graph is going to be, we gave in basics, change in y-axis by change in x-axis. So that is only dp by dt. So if they give theta, let us assume, then tan theta gives slope of that graph. This is how they are going to do. What is the area it is going to be given? What is the area means product of y-axis and x-axis. If it is triangle shape means area of the graph of dp into dt, product of momentum and time. Isn't it? That information you are going to get from this graph if they give graph drawn between momentum and time. Isn't it? Now, whenever we are calculating, what we have to calculate first means to get the force, we should calculate change in momentum. So the change in momentum in how much time? If we calculate, we are going to get the force. And another important definition from this, you will get force into time. So this force into time, we are calling it as impulse. Large force in small interval of time. So this change in momentum is going to be equal to impulse force into time. Now see, if they gave graph run between force and time, now what is the slope of force and time means df by dt. This is slope. What is the area of force and time? So area is going to give half force into time. So this force into time we are calling it as impulse or change in momentum, isn't it? So area and the force time law. So like this they are going to ask. Next, if you integrate this, integral dt, integral ft. If you integrate this, you will get momentum. T is equal to integral f dt. Time is changing from some value to some value they will put. So at the time we have to use this equation. So first we will see about force. In how many cases force is going to come. To see the force, we require change in momentum. So how we are going to get change in momentum? So let us assume an object is going to hit. An object is going to hit vertical wall or a ball is going to hit. With what velocity you are hitting? With the same velocity, let us assume it is coming back from there only. Just for understanding, I am drawing here. It is coming with same velocity. In this direction, we will take minus u. In this direction, we will take plus u because positive x-axis, this is negative x-axis, correct? Now, what is the change in momentum? So, delta p, final momentum minus initial momentum. What is the final momentum here? Minus mu minus, what is the initial momentum? Mu. So, minus 2m. This is the change in momentum. So this negative sign represents. What is this negative sign represents means it is away from the wall. Which is away from the wall? Change in momentum is away from the wall. So what is the magnitude of change in momentum means? 2 mu. Now how much force is acting on this wall by this ball means you have to take how much time this change in momentum is occurring. So you are moving towards the wall. So you are starting from rest, u value 0. Whenever you are moving, suddenly you are hitting the wall. Then your velocity becomes 0. Means some amount of force applied by you on the wall. At the same time, reactant force, wall is also applying same equal and opposite force on you. Therefore, you are going to hurt, isn't it? Therefore, you will get pain. because suddenly your momentum became 0. So change in momentum with respect to time only, we are calling it as force. So therefore, you have to divide with the time, this change in momentum, then you are going to get force. So here it is going to hit normally with the wall. So it is making 90 degrees with the wall. If it is making some angle, then what is the change in momentum? So whenever ball is hitting the wall with initial velocity u, okay, by making an angle theta. So theta here, one time they will give with wall, one time they will give with normal. Here I am taking with normal. After hitting, it is coming like this with the same velocity, with the same angle here. Then what is the change in momentum they're going to have? So this u we can resolve very easily. This u, reflecting u. So this is going to be u cos theta. This is going to be u sin. Same like this, if you are taking this u. So this is making how much angle with horizontal? This angle will be same. So therefore, always, which is base in theta, that is u cos theta. Remaining side is u sin theta. This is resolution of a vector. We discussed all these in basics, correct? Now, we can observe one thing. So u sin theta, both are in same direction, that is downwards. Therefore, change in momentum along wall. Change in momentum along wall. That is nothing but y-axis. Is going to be 0 because mu sin theta minus mu sin theta. Final momentum minus initial momentum. 0. So always change in momentum along the wall is 0. Now what is the change in momentum perpendicular to wall? So in previous case, in place of minus u, now what is there? Minus u cos theta is there. In place of u, what is there? U cos theta is there. See, u cos theta is there. Therefore, u cos theta is like this towards the wall, u cos theta. U sin theta is minus u cos theta. Minus u cos theta is away from the wall. U sin theta is along the wall. Both are in same direction. So both are equal and opposite. Therefore, change in momentum is going to be, again you will get minus 2mu cos theta. So this is the change in momentum whenever theta is making with normal. Sometimes this theta they will give with wall. Whenever they are giving with wall, what we have to get here? Here you will get sin theta. So you have to see very carefully. With normal they are giving, with wall they are giving. Isn't it? So this is change in momentum, how to calculate. Once you got change in momentum, we are going to get force. Understood? This is about change in momentum which is away from the wall. This negative sign indicates. Correct? Next, so this model only in 2025 they gave one question. An object is dropped from certain height, h1. It is rising h2 height. Okay? How much impulsive force is going to act? So impulsive force means that is nothing but change in momentum according to our definition. Impulsive force in the sense change in momentum. So now how the change in momentum you are going to get means here u downwards, v upwards, let us assume. So downwards we will take positive or negative. So downwards is nothing but minus y-axis. Therefore minus u. Upwards you will take plus. Therefore what is the change in momentum? So change in momentum is nothing but final momentum minus initial momentum. What is final momentum here? mv minus, what is the initial momentum? Minus mu. Understood? If mass of the object. Therefore, mv plus mu. Here you got change in momentum positive because change in momentum is along positive y-axis. Correct? So wall is like this means change in momentum towards left side. Same like that, wall is like this means change in momentum will be right side. So here direction is also going to be important because change in momentum is nothing but vector form. This is mv plus mu. So in place of u, if it is coming from h1 height, what you will be getting means. So what you will be getting? U is equal to root 2g h1. Therefore, so m, what is u now? Root 2g h1. What is v means? Root 2g h2. So blindly you can remember both are moving in opposite direction before hitting, after hitting. In between you will get plus. So here depending on the direction, whether you will get negative sign or positive sign, which where change in momentum. If wall is like this is nothing but floor. Therefore change in momentum above y-axis. Above, it is going to represent positive y-axis. In this case, change in momentum towards left side, therefore negative. In this case, change in momentum towards right side, therefore this is positive. So this is the change in momentum. So they asked the impulse, therefore change in momentum, we should calculate, isn't it? If they give time means they will ask force. So force I will calculate means divided by time. So blindly we can remember change in momentum gives impulse, change in momentum by time gives force. If you remember like this, definitely you can solve problems very easily. But don't remember force is nothing but only F equal to ma. F equal to ma correct only, but it is going to be in case of only constant mass, if mass is constant. Now, how acceleration is going to be changed? Acceleration we will get two terms. One is dv by dt, another one is v dv by dx. How they will ask question from this? dv by dx, they will give velocity distance graph. Mass of the object they will give. Then what is the force they will ask? Then slope of velocity distance graph gives dv by dx. So if you apply like this mv dv by dx, then you are going to get force. So one is by changing momentum, another one is by acceleration. By using these equations also we can get the force, isn't it? So now practice by changing momentum where you have. Okay, so we'll see in remaining class. Thank you.